Hey everybody, I wonder who out there has worked with scale models before? Anybody play with Legos or Hot Wheels or dolls, like American Girl doll, or maybe you built models like these on Amazon. I was checking out. I was like, ooh, I kind of want these. Here we have some scale models that are not actually the size that they are in real life. Surprising. This one is 1 to 32 scale. All right, so that means that the um, any piece of this, let's say the length of the wing here, if you multiply that length by 32, you would get the actual length of the wing. Here's a 1 to 48 scale, so if you measure this propeller here and multiply it by 48, you get the actual length of the propeller. Okay, so here's some 1 to 35s. These are mostly 1 to 35s. You see the fraction, it's written sometimes as fraction and sometimes with the two dots. Here on the box, it has the two dots. All right, so maybe you're a model train person or your family gets one out for the holidays every year. Anyway, that is um, some examples of where you might see scale drawing and scale models. All right, so we are going to get right to it. All right, scale drawing and scale models. They're used to represent an object that's too large or too small to be drawn or built at actual size. Also, the lengths and widths of objects on scale drawing or model are proportional to the lengths and widths of the actual object. Okay, the scale is determined by the ratio of a given length on the drawing or model to its corresponding length in the actual object. This is really important. That, see, the way we say the ratio tells us what to put first when we actually write it out with numbers. So it says that the drawing or model, it's a ratio of the drawing or model to the actual object. All right, and you can see it right here, 1 inch equals 3 feet actually means 1 inch on the model represents an actual distance of 3 feet. And 1 centimeter equals 2 millimeters, so you can read that. 1 centimeter represents an actual distance of 2 millimeters. Okay, this is very important. Scales are written so that the unit length on the drawing or model is listed first. So the lengths on the drawing or model always first or in the top, the numerator, when we write it in fraction form. You can see that model length versus actual length. Always that model length on top, actual length on bottom. All right, let's talk about these dragonfly models. Okay, we have a dragonfly model that has a wing length of 4 centimeters. It's if the length of the insect's actual wing is 6 centimeters, what is the scale of the model? So we're trying to find the scale. So we're essentially simplifying this down so that the first, the model length is 1. So whenever we're finding a scale, we want the model length to be 1. Just like on the Amazon one, it's always say 1 to 72, 1 to 35. Right? We had a 1 to 48 up here somewhere. Okay. Anyway, so this there it is, 1 to 48. We want it to always have, right, that model length or drawing length to simplify down to 1. So we can cross multiply to figure out what that missing number is, like they did. Or we can just divide the top and bottom by 4. If we divide the top by 4 and get 1, we can divide the 6 by 4 and get 1.5. All right, so 2 methods for that. Try these 2 guides. Find the scale for each of these models. All right. Okay, here are the answers. Check and see if you got it. Moving on now, we're going to use this idea of scale factor, and that is slightly different than scale. All right, actually, I was showing you in the Amazon, these are all scale factors, although they don't say it on these, they say scale, but scale factors because there's no units. Okay, and it's actually how much bigger, how many times bigger the actual is than the drawing or model. Okay, so those pictures actually show the scale factor, which is no units. So here we go. Moving from scale to scale factor. Notice a scale has units and they're different. All right, 1 inch represents 2 feet. How do we fix that? Or how do we change it to a scale factor? We have to get them to be the same unit. So look, write it as a fraction. Now convert the feet to inches, so 24. And now we can do our dimensional analysis, cancel out those inches, right? And now we just have a scale factor of 1 to 24. The actual object is actually 24 times, all the lengths are 24 times longer than the lengths in the model. All right? So 1 unit on the model represents an actual distance of 24 units. Okay, and here, so the model's 1/24th the size of the actual object. Okay, so that's important skill to have, is changing from scale with 2 different units to giving them the same units and canceling out those units, and then having the scale factor, which is the ratio without units. All right, here we go. So on this example, we got the blueprint of a skateboard ramp shows that its length is 11.4 inches. If the scale on the blueprint is 1 inch to 6 feet, what is the length of the actual skateboard ramp? All right, well, we see that we've been given the scale and we've been given 1 length. So what we're going to do is we're going to set up a proportion to figure out the other length that we don't have yet, which is the length of the actual skateboard ramp. Okay, so plan to actual, and this is our proportion here, set up beautifully. So the scale, we typically write that first in our proportion. A proportion is 2 equal ratios or equal fractions. We set it, so 1 inch to 6 feet. All right, and then we've been given this this blueprint length. So that would go on top because it's part of the plan, right? It goes on top and it's in inches, so we want it to agree because these have to be equal. They have to be the same. All right, whereas in dimensional analysis, we always put units like a diagonal from things to cross out. We don't want that in this. These are things that are equal. That was it. That was when we were multiplying and wanted to cancel out. These are equal, so we have to line up the right units. All right, so the actual length, we don't know what the real length is going to be. So we have the plan length. We need to figure out the actual length. So we can cross multiply just like they showed and divide to get 68.4, which would be 68.4 feet. Excuse me. All right. The other way to do it is to do it with scale factor. All right. So you can figure out, oh, well, let's do just what we did up here, right, to get the scale factor. So we want to convert to the same units and then cancel out those units. And then we have our scale factor. So we know that if we have a length, right, if we have a length given to us of 11.4 inches, all we'd have to do is multiply it by that 72 to get the answer. Okay, so they're writing an actual equation for it, just like we have in the past, where if we can find that multiplier in a proportional relationship, we can write an equation. All right, so the actual length, which is A, and the blueprint length, which is B, okay, we know that the actual length is always 72 times bigger than the blueprint length. All right, and we found that by that multiplier by changing it into a scale factor from a scale. All right, you can choose the way you want to do it right here. All right, try that one and see how you do. There it is. There's the answer. Hope you did all right. And if you need help, just let me know and I can help you through that one.